Hi everybody, it's Lynn, and I'm going to talk today about dimensional analysis. So dimensional analysis is simply a fancy word for a problem-solving method that we're going to use in this class. And it's a method that is used for converting between different units of measurement. And it's really helpful throughout all of chemistry, but also in pretty much any future math or science class that you take. So on this first slide here, I have kind of the step-by-step method. And on the next several slides, I'm going to do a couple of examples. So first, it's always really important that you read the problem carefully. And in particular, in dimensional analysis, we want to identify the given quantity and measurement and the unknown. And that sort of gives you, a starting and an ending point for your dimensional analysis. And then we're going to use a setup where we essentially set the given and the unknown equal to one another. We say something along the lines of how many centimeters are there in 54.5 inches? So how many of the unknown unit are equal to a measured number value of the given unit? And then we're going to create what are known as fraction style ratios. So these are the mathematical equalities that we use to compare two units, that connect the units. So instead of saying 100 centimeters is equal to 1 meter, we would make that into a fraction where 100 centimeters could be in the numerator and 1 meter could be in the denominator, or vice versa. We could flip it on its head and have 1 meter in the numerator and 100 centimeters in the denominator. So because we have those two choices, now we have to orient the fraction style ratios so that the units are going to factor out or cancel and leave you with the desired unit, which is the unknown unit. So once you have your setup and your fraction style ratios lined up, then you need to grab your calculator. You're going to multiply everything in the numerator of all of these fractions that you're multiplying together and divide by everything in the denominator. And then your calculator garbage, which is just all of the digits that your calculator gives you, will need to be rounded so that the significant figures in the answer match the significant figures in the original given measurement. And finally, we don't want any naked numbers in this class, so we want to make sure that you have units on your answer, which should be the unknown units. So here's an example. So here's an example where the question is how many inches are in 27.4 centimeters. So I'm just going to annotate this slide a bit. And so first I want to identify my given and my unknown. So my question is asking about inches. So that would be my unknown value. And my measurement that I have given is the centimeters. And so I can put those values and those units in the given and the unknown setup of the dimensional analysis. So I don't know how many inches, but I want to know how many of inches are going to be equal to 27.4 centimeters. So up at the top of the page, I have fraction style ratios, which show the relationship between inches and centimeters. And these are not things that you will have to memorize. These are things that will be provided for you. So the relationship between inches and centimeters is that 1 inch is the same as 2.54 centimeters. And so when we write those fraction style ratios, I can either have the 1 inch in the numerator or the 1 inch in the denominator. And so when I'm choosing which one I want to use, you can think of this first value as being over an imaginary 1. So I want to line up my fractions in such a way that my units will factor out or cancel as these fractions are multiplied by each other. So because centimeter is in the numerator of the given, I want centimeter to choose the centimeter to go in the denominator. I want centimeter to go in the denominator of my chosen fraction style ratio. So that way, as I multiply these fractions, the centimeter is going to factor out with the centimeter, and I'm going to be left with a value of, or a unit of inches. So essentially, my math here is 27.4 times 1 in the numerator, which would just be 27.4. And you wouldn't have to actually do this step. At this point, you would be grabbing your calculator. And it's 2.54 in the denominator, so I'm dividing by 2.54. 1 times 2.54, if you really want to get specific there. So I'm going to go to my calculator. It was 27.4 divided by 2.54. And I get 10.7874, right? That's calculator garbage. Your calculator does not understand significant figures. So you have to round this answer so that you get the correct significant figures. And so since my original given measurement, 27.4, has 3 sig figs, I want to round the calculator answer to 3 significant figures. So I'm going to cut it off after the 7. And since the digit immediately after that is 5 or above, I'm going to round up to get my final answer. Excuse me, get my pen back again. My final answer is going to be 10.8 inches. So don't forget your unit, no naked numbers. So 27.4 centimeters is the same length as 10.8 inches. Okay, let's move on to our next example, which requires a couple of fraction style ratios. So this just used one fraction style ratio. So next, we have how many kilometers is equivalent to 2,700 feet. So kilometers is our unknown. 2,700 feet is our given. So the unknown is how many kilometers. And the given is 2,700 feet. And you can think of that as being over 1 if it helps you sort of line up your fractions better. So over on the top right of our screen, I have now 2 different fraction style ratios. One that connects feet to mile and another one that connects the mile to kilometer. So I'm going to need to choose one of each of the blue fractions and of the green fractions. And I want to orient them in such a way that the units factor out or cancel as the fractions are multiplied. So since I have feet to begin with, I'm going to look for the fraction first that has feet in it, which is either one of the green ones. And because this green one with feet in the denominator will allow the feet to factor out as the fractions are multiplied, that's the one I'm going to choose. So essentially I want to choose the fraction that will get me from feet to miles. So my given unit is in the denominator and where I'm going is in the numerator. So that would allow me to factor out the feet as these fractions are multiplied. And now I'm left with mile, but I don't need mile as my answer. I need kilometer as my answer. So now I need to choose one of the two green fractions. I want to factor out mile and I want to end up with kilometer. So that means I need the mile to go in the denominator and the kilometer to go in the numerator. Just making sure my fraction will come to the front. And so if I choose that one, now the mile units factor out and I'm left with kilometer, which matches my unknown, matches where I'm headed for. The feet have gone away, the mile has gone away, I'm left with kilometer. And so now I need to multiply everything in my numerator, which is 2,700 times 1 times 1. We don't actually have to type the ones into our calculator. And then we need to divide by both 5280 and 0.62137. So there's a couple different ways you can do this. You want to make sure that your calculator understands that it is dividing by both of those numbers. So going over to the calculator, clearing out what we have, we had 2,700 in our numerator, and we want to divide by 5,280. And we also want to divide by 0.62. Sorry, I lost my conversion factor, 137. So notice that I put divide and divide again. So that's one way to speak calculator. Another way to do that would be to divide with parentheses. So 2,700 divided by parentheses, and then the 5,280 times the 0.62137. So the main thing you don't want to do is accidentally multiply by one of those numbers. So you need to make sure that the calculator understands that you're dividing by both of them. So now again, I have calculator garbage. I have a long decimal number for this answer. I need to determine how to round that answer according to the significant figures. So 2,700 has 2 significant figures. My original measurement has 2 significant figures because the zeros are not significant. So I need to round 0.82296 to 2 significant figures. Starting from the left, the 8 is the first sig fig, then the 2. So since the digit immediately after that is less than 5, we keep it as 0.82. So my final answer here would be 0.82, don't forget your units, kilometers. And so again, essentially what I've done is I've taken the same amount of length and I've expressed it into a new unit. So 2,700 feet is the same amount of distance as 0.82 kilometers. Thanks and good luck with your dimensional analysis practicing.